Okay, so remember our learning target is today you will write and interpret numerical expressions and compare expressions using a visual model. So remember that an expression is something that does not have an equal sign. Although when we are interpreting and evaluating an expression, that means we're going to actually solve it. So at that point it becomes an equation because it has an equal sign. All right, so let's take a look at another problem. So here we have the sum of 2 12s and 4 3s. So first let's start out by drawing a tape diagram of that. So if I have 2 12s, I'm going to show that as 12 and 12. And then I have 4 3s. 1, 2, 3, 4. If I want to find the sum of those, that means I want to put those all together. Okay, so my expression is, first I have to find out what my 12s are, so I'm going to write that as 12 times 2, because I have 2 12s, and then I have 4 3s, so 4 times 3, and then I'm going to add those two things together. Okay, now think about, why do I need to put those parentheses there? Actually, I don't, because this would be exactly the same expression using our order of operations when we have parentheses, exponents, multiply, divide, remember those are on the same level, and then add and subtract, also on the same level. If we look at this, we would solve our parentheses first. Here, without parentheses, I would still solve my multiplication problems first before getting to the addition. So to find the value of the expression, let's rewrite it. And I'm going to organize my thoughts. And the way I'm going to organize my thoughts is I'm going to solve using my steps. If I look across, I don't have any parentheses. So I'll go to the next letter. Exponents. I don't have any exponents in this one. So now I'm going to look at the multiplication and division steps. And I'm going to solve those in order from left to right. So I start here. 12 times 2 is 24. Then I'm not adding anything because that comes next. 4 times 3. 4 times 3 is 12. So that goes here. Now I go back and reevaluate, and I'm at the adding and subtracting step. So I'm adding 24 plus 12. 24 plus 12 is 36. So the value of this expression is 36. Okay, now let's look at another one. This one says the sum of 2 19s and 8 19s. So I have 2 19s and 8 19s, and then I'm finding the sum of those. So first I'm going to draw a tape diagram. Here I have 2 19s, and then I have 8 19s, okay, so that shows my representation, and I want to find the sum, which means I want to find out how many I have in all. So to write an expression for this, I'm going to show that I have 2 19s first. That's 2 times 19. And then I'm adding that to my 8 19s. You'll notice there's another way that I could express this. I could say 19 plus 19 plus 19 plus 19 plus 19 plus 19, all the way until I get to 8 19s. Those are actually going to mean the same thing. And again, I don't have to have those parentheses. For me, it just helps me to clarify that that's where I need to stop first. So I usually put the parentheses, but they are not required. So this expression would mean the same thing with or without parentheses when I use my order of operations. So if I start with my order of operations, please excuse my dear Aunt Sally. It tells me first I'm going to look for parentheses. There's no parentheses in this expression. If there were, I would go ahead and do that first. So let's go ahead and put parentheses just to show that we're going to do that first. 2 times 19 is 38. I'm going to just put that there to show that that's my first part of my expression being solved. And then I have 8 19s, which is 152. Now I can go through and look. I don't have any exponents. I've done my multiplication and division, so now I'm at adding and subtracting. So I have 38 plus 152, and that is equal to 190. Okay, so let's take a look at one more. Actually, I think there's several more. This time we have 5 times the sum of 16 and 14. So when I start out, I'm going to have the sum of 16 and 14. The sum means that I'm adding. And I'm going to have that 5 times. So that's the first time, second time, third time, fourth time, and fifth time. And I can represent that to show that each time that box is equaling 16 plus 14. So not 6 plus 14, 16 plus 14. So if I write that as an expression, I'm going to solve 16 and 14 first, and then I'm going to multiply that by 5. So think about this. Does it matter if I have my times 5 in the front or at the end? Okay. Technically it doesn't matter because either way I'm going to do what is in my parentheses first. However, when I see this 5 times first in the sentence, if I'm representing what the words are saying, I want to go ahead and put that at the beginning of my expression so that what I see is exactly represented in these words. And that is that 5 times the sum of 16 plus 14. Okay, so now let's find the value of the expression. Remember, we're going to use PEMDAS. Parentheses comes first, so 16 plus 14 is, rewrite this real quick. 16 plus 14 is 30, so that was that solved. And then I'm multiplying that times 5. 5 times 30 is 150. So you'll notice if I didn't have those parentheses on this particular problem, that would mean I would have a different answer when I got finished. Because first I would need to multiply 5 times 16, and then I would add 14 to that product. That is not what my statement up here says. So without the parentheses, it would be considered an incorrect expression for that statement. Okay. All right, so now we're back to our problem of the day. It says in the new SLP store, students can buy the following: Airheads for 73 cents, a bracelet for $3.42, a fidget spinner for $5.71, Smarties for 24 cents, and a blow pop for 53 cents. They will also sell a jumbo box that has one of everything included for $12.38. So Landon decides to buy 3 Airheads, 6 blow pops, a bracelet, and a fidget spinner. He wonders if he should buy the jumbo box instead since it has everything in it. So part A says, write an expression to show how much Landon will spend to buy 3 Airheads, 6 blow pops, a bracelet, and a fidget spinner, and then solve the expression. So I'm going to have 3 Airheads. So I want to start with my Airheads, which is 3 at 73 cents each. Plus he's going to buy 6 blow pops, so that's 6 times the price of a blow pop, which is 53 cents. Then I'm going to buy a bracelet, which is $3.42. Plus I'm going to buy a fidget spinner, which is $5.71. So to solve that expression, I'm going to start out by multiplying and solving for inside the parentheses. So 3 copies of 73 is going to be $2.19. And 6 copies of 53 is going to be $3.18. And then I need to add in my other 2 amounts. I'm going to do that over here to the side. I have $2.19 plus $3.18 plus $3.42 plus $5.71. So 9 plus 1 is 10, 8 plus 2 is 10, so I have 20 here. 7, 11, 12, 13, 14, 15. 5, 8, 10, 13, 14. So Landon is going to spend $14.50 on the items that he wants to buy. So part B says, is the jumbo box a good deal? Compare the total cost of buying one of everything with the cost of buying just the jumbo box. Which is the better price? So what we need to do first is to find the total cost of buying one of everything. And we're going to compare that with the cost of the jumbo box. So if Landon was to buy one of everything, let me erase this work so that we can see the cost of one of everything. I would have 73 cents, $3.42, $5.71, 24 cents, and 53 cents. I'm adding those all together. So 7, 8, 9, 10, 11, 12, 13, 11, that's 14, 18, 20, 25, and I carried a 1, 26, 8, 9, 10, 11. So $11.63 to buy one item, and I'm comparing that to $12.38. If I was to line up my decimals to compare those two values, my tens are the same, my ones are different. 11 ones is less than 12 ones, so $11.63 is less than $12.38. So the better price is to buy one of every item. Okay guys, so let's get ready to take a look at our problem set. Be sure that you're focusing carefully on making sure that your numbers and expressions match exactly what the word says. And you want to make sure that every single time you have one of these problems that you're using the please excuse my dear Aunt Sally method, parentheses, exponents, multiplication and division, then adding and subtracting. That is called our order of operations, and we have to follow that every single time we solve a problem in math.